Hi, I'm doing this video. I'm Mrs. Schwans, and I'm doing this video to help you add fractions. So let's say that you want to add 1/3 plus 1/4. Or let's just make it a little bit more interesting. Let's say 2/3. We'll just 2/3 plus 1/4. Well, here's a little hint that I recommend whenever you're doing math, write out the problem and try to write it out in the same way. So every time that I see an addition problem like this, I know that I have to find common denominator, and so I add vertically. See how this is horizontally adding? I'm going to do it a vertical problem. And the reason why I do that is because I know I need to build fractions that have the same denominator that are equivalent to 2/3, and a fraction that's equivalent to 2/3 that has the same denominator as a given fraction that's equivalent also to 1/4. So we have to find the least common multiple. To do that, to find the least common denominator for LCD, you find the least common multiple of the denominators. Now, a multiple is a number that's larger than either denominators that is divisible by both the denominators. Both denominators divide into this number, and that students get that a lot confused. And I think they're getting confused because the word least. Now, let me just focus on this now to help you in the future, and it's just a steady habit as a student. Sometimes when we see really big, long, complicated words or terms, what we need to do sometimes is we need to block out some of that information and just say, I'm going to put this on the back burner right now. I'm going to focus on this part and understand this little part of it now, and then I can bring back all those more difficult terms as well. So that's what we do when we think about least common multiple. We just focus on the word multiple. And a multiple means that it's like a multiple of 3 is several threes, like 3 threes or 2 threes or 4 threes or 5 threes, or it's the result of taking 3 and multiplying by another number. So like 3 times 4 is 12. So 12 is a multiple of 3 because it's 4 threes. Okay, so, and then now we can add in the word common multiple, meaning that it's going to be this number has to be a multiple of 3, and it has to be a multiple of 4. And so one way of finding a least common multiple is just listing all the multiples of 3. So 3, 6, 9, 12. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 20, 3 times 6 is 24, 3 times 7 is 28, and so on. Okay, so list all the multiples of 3 and then list all the multiples of 4. 4 times 2 is 8, then 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, and so on, right? Okay, now that we understand the multiple, I mean, a common multiple would be a number that's listed in both this list and in this list. So we see some common numbers here, like the 20 is listed in bold and the 24 is actually listed in bold. Wait a second. Did I do that correctly? 8 times 3 is 24. 28 is wrong, I believe. I should not have, sorry about that. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is not 20. 3 times 5. 3 times 5 is 15. 3 times 6 is 18. 3 times 7, 21. 3 times 8 is 24. 3 times 9, 27. Okay, that looks much better. Now 4 times 4, and let's just make sure that they go up by 3, right? Because they should increase by 3. As a double check. Okay. And then 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32, and 4 times 9 is 36. Okay. And they all go up by 4. Okay. Oh, all right. So now we see that like 24 is a common multiple. So it's a multiple of both of the numbers. Another way of saying this number is, it's a number that 3 goes into equally with our remainder. We say that 24 is divisible by 3 because 3 goes into it equally with our remainder. So that's another way of saying, instead of common multiple, we could say it's a number that's divisible by 3. It's divisible by both numbers. That's how I kind of always think about it as a student. When I find the least common multiple, I'm actually looking for the number that is divisible by both 3 and 4. And that's because we have to take 3 and multiply by some number to get this common denominator. So it has to be divisible by 3. 3 has to go into equally. And the same thing, I have to take 4 times some number to get this common denominator. So it has to be divisible by 4. So we need a number that's both divisible by 4 and by 3. And 24 would be a number, but we have to find the smallest number. And that's where this word least comes in. We want to find a common multiple, but ideally it would be the smallest. And this is not a necessity. It doesn't have to be the smallest, but it's just to make our work better, work easier if we take the smallest. So this is 12. It looks like the smallest number that is a common multiple to both is 12. So that will be our common denominator, okay? So that took a little bit of work. We can learn to do these common multiples on a calculator. I just feel like it's really tedious, and it's much better if it's almost just as hard to remember how to do the calculator cheat method of having to find all these common multiple as it is just remembering the process yourself. And it's just gonna make your calculations later in life easier if we just do this real quickly. And when we get algebraic expressions, I'm not sure if your calculator can do least common multiples of algebraic expressions, and that's why it's important for you just to be able to know it, period. So I find for me, it's just so cumbersome to so often the calculator puts it in the wrong format. They have it in decimal format, and I want a fraction format, and the calculator is rounding off numbers. And so I've found in the past it's much better for me if I have fractions in an expression just to not use my calculator and just do it in my own head. So anyways, we did all of that work just to find a common denominator here. And there's a much simpler and easier way to find least common multiples and least common denominator. And but for this moment, we'll rely on just listing the multiples and finding the smallest. So 3 times, now we need to build a fraction that is equivalent to 2/3 that has a denominator of 12. So I noticed that I have to ask myself, well, I had to take this original denominator of 3 and I had to multiply by what to get this new denominator that I wanted of 12. So I had to multiply by 4. So whenever I do the numerator, I have to do the denominator if I want to make this an equivalent fraction. So 2 times 4 is 8. So notice how now we know that these are 2 equivalent, 2/3 is equivalent to 8/12. And I know that because if you think about it, we multiply the numerator by 4 and the denominator by 4, but that's actually a 1 in disguise. So I actually took, because 4 over 4 is 1, I took 2/3 and multiplied by 1. I should get, there's a rule that anytime I multiply by 1, by any integer, I should get back the same number. 1 has a property of when you multiply by 1, you should get your same number back. So I got my same number back, but just in a different version of itself. And I know that's really hard for some students to wrap around their mind, that 2 over 3, 2/3 here, is equivalent to 8/12. And that, I think, that's why fractions are hard for students, because they just don't mesh with other, like the things that we do with whole numbers. Like you'd never say, oh, 2 is equal to 3. You'd never say that. So why are we saying 2/3 is equal to 8/12? So I think it's just mind-boggling, and it's something difficult that you just can't accept, but you just take a deep breath and you just say, okay, that's the way they are. We're just gonna accept it, okay? All right, and then, so now I do 4 times what equals 12? Well, 3, 4 times 3 equals 12. Well, I have to, whatever I did multiply this denominator by 3, so I have to multiply the numerator if I want to keep an equivalent fraction over here. So 1 times 3 is 3. So 1/4 is equivalent to 3/12. And you can see that if you reduced 3/12 divided by 3 on top bottom, you would get back to 1/4. So we do know there's the equivalent. So now what's going to end up happening, instead of me adding 2/3 plus 1/4, I'm going to add 2 fractions that are equivalent to 2/3 and 1/4, and that way I can get my final answer. So I now add them together. I just add the numerators together, and that's 8 plus 3 is 11, and 1 and 12, and I keep the same denominator, 11/12, and that is my answer. All right, so we had some steps here. I originally took a problem that was written horizontally, and I wrote the problem vertically. It's here, do you see that? And then I immediately said, okay, I need to build fractions with the same denominator so I can add them. And then I went about finding the least common multiple of the denominators so that I could find the common denominator that I needed to build the fractions to. And then once I built my equivalent fractions, then I just added those equivalent fractions, and I added the numbers in the numerator and kept the same denominator, and I'm all done. So I hope this is all really understandable to you. And if you want to keep listening, I'll show you another way of finding the least common multiple. And if it's a faster, more efficient way, and that way you can use that from now on, right? But if not, then we can go. But here is how I would find the least common multiple of, and I'm not going to use 3 and 4 because those are so small numbers that I don't really want to use those numbers. Let's think about if I had denominators of 12 and 16. What I would do to find the least common multiple, so the LCM of 12 and 16. If I wanted to do that, I would prime factor both. I factor 12, and then I factor it again and again as far as I factor each factor again and again as far as I can go. Then I take 16 and I factor that one. Now what I do is the LCM, it contains, now LCM, the requirement here, the LCM contains all the prime factors of 12, which, let me write this down here at the bottom. 12 was 2 times 2 times 3. And it must contain all the factors of 16 as well. Okay? So the first thing I do when I'm doing the LCM is I go to my first number and I just wrote down all the factors of my first number. 2 times 2 times 2 times 3. Okay? And that's just a fact. If I want this number to be a multiple of 12, it's got to contain the prime factors of 12. That's the big takeaway that I want you to remember. If our least common multiple has to be a multiple of 12, in order to be a multiple of 12, it has to contain the prime factors of 12. Okay, so I just took all the prime factors of 12 and added it to the LCM. Now, carefully listen here. In order for our LCM to be a multiple of 16, it has to contain all the prime factors of 16. However, these could overlap. So it could use some of the factors that are already down there from the 12. It does not need to add more. So so it has to have 4 2s, but it already has 2 2s coming from the 12. So we don't need to add all 4 of those. We just need to add 2 more. Okay, so now I look at it and I ask, does it have 4 2s, which are the prime factorization of 16? Yes, it does. Does it have 2 2s and a 3? Yes, it does. So therefore, this is the LCM of 12 and 16. And we can, when we multiply it out, we actually see the actual number. So it is going to be actually all the 2s multiplied together were 16 times another 3. So 16 times 3, which we believe is 48. That's 16 times 3, 48. Yes. So that is our LCM of 12 and 16. Okay. And so that is the way to do it. I've seen other teachers, what they do is they have the prime factors of 12 and they put it in here, and they have the prime factors of 16 and they put it over here. And the numbers that they're sharing, like the 2 2s, they both have 2 2s. They put them in this center area of the Venn diagram. And then there's a 3 over here, and there's 2 more 2s over here. And now they just write down all of this. But the 2 2s only get written one time because they're in the intersection of the both. They're common to both. So they only get written one time, but this is the LCM. So what all you do is you do the prime factorization, and you just put it in a Venn diagram. The ones that are common to both go in the middle, and the ones that are only belong to 12 or only belong to 13, you write on the outside, and then that's the LCM. But it works because the ones that are in common in the middle, they don't get written twice. They only get written once. And that's what we want. We don't want to double use anything, because like I said, it just has to contain 4 2s. I could steal some of the 2s from the 12, the factorization of 12, it doesn't matter. Because when we look at it once at a time, I have to say, does it have all the prime factorization of 16? And does it have all the prime factorization of 12? But they don't have to have all of that at the same exact time. They don't have to, well, they do have to have it at the same time, but they don't have to have double, like some extra for 16 and for 12, right? They can share the 2s. All right. I hope you found this video very helpful. Have a great day. Bye.